Welcome back. Now, in the last video, we did a box trace, and we used a T-array in order to add some actors to ignore to our box trace. And I mentioned that this T-array is Unreal Engine's built-in array type. Now, there's a reason to use the T-array rather than a regular C++ array. So we're going to talk about the differences between regular arrays and the C++ T-array. In regular C++, you would make an array like this, where you would specify the type that the array can store. In this case, we may wish to store enemy pointers. And we have to specify how large the array is. In this case, our array can store 5 enemy pointers and no more. And the reason we have to specify this is because at compile time, we need to know how much memory this array is going to take up. It's going to take up the size of an enemy pointer times 5. So the memory is allocated beforehand, and even if we never fill this array up, it's still taking up 5 enemy pointers worth of memory. Now, with regular arrays, the array indices start at 0. So the very first element in the array has array index 0, and the next one has array index 1, and so on. So our 5-element array has indices 0 through 4. Now, we may wish to place the address of an enemy in our array at the index 0. So this results in our array now having valid data in its first element, element 0. And we can continue this process specifying which index to insert our enemy pointers into. Now, there's always the danger of attempting to access an element that does not exist in our array. Our indices range from 0 to 4 in this array, so if we tried to store a pointer in element 5, that element doesn't exist in the array, and this is how we get a crash. This is known as the array index being out of bounds. Now let's talk about dynamic arrays. Regular C++ arrays are static. They're not dynamic in a sense that you can't just add any number of elements to them. As we mentioned, we have to specify how many elements can be stored in the array right off the bat at compile time before the program even runs. A dynamic array is different. They're typically templates, allowing us to specify the type that we're going to store in the array. So we can create a new array called enemies, designed to store enemy pointers. Now, a dynamic array is a bit more complicated than a regular C++ array. It's a class or a struct that has its own member variables and functions, and we're typically sheltered from the interior workings of the dynamic array. We don't have to understand how it does what it does, we just have to know how to use it. But at a high level, here's how they work. They start off with a static regular C++ array with a fixed length. In the diagram here, you can imagine that this enemies array starts off allocating memory for 5 enemy pointers. Now, these dynamic arrays have their own functions for adding elements to the array. They typically have a function called add or something similar. So if we take our enemies array and call its add function, passing in a pointer to store in the array, then our dynamic array object will perform any checks that it needs to under the hood for us and then add that element into the first available slot in its internal C++ array. So we can keep calling add, inserting elements into the array as often as we like. Now, eventually, that internal regular C++ array could be filled up. Now, the danger still exists that we could index an array element out of bounds. If our dynamic array only has 5 elements in it, with indices 0 through 4, and we attempt to access the array indexing element 5, which doesn't exist in the array, well, then we'd still get a crash because we're indexing an array element out of bounds. So we still have to keep that in mind. So how do dynamic arrays allow us to simply call an add function without remembering how many elements there are in the array? Well, what they do is they have their internal array, and every time we add an element to it, the array keeps track of how many elements have been added with some sort of variable called num, short for number, or something similar. So our dynamic array object has this num member variable we can access to check, as well as the add function. It also has the ability to remove elements from the array. So how does the array accommodate for any number of elements if it only has a certain amount of memory allocated from the start? Well, here's how it works. We use our add function to add an element to the array. At this point, our add function knows we're adding an element into the array, so it can update the num variable. It'll now be 1 because we have a single element. Now, if we call add again, our dynamic array will insert that new element into its internal array and update num to 2. Continuing the process, we can call add again, and our array will add that third element, updating num to 3. And we can call add again, we'll get a new element, num will now be 4. And finally, we'll call add a fifth time, we'll get that fifth element, and num will be equal to 5. And at this point, we see that we've filled up that internal array. So what happens if we call add again? Well, what the array is going to do is see that that array is now full, and if we call add a sixth time, then our dynamic array will create a new C++ style array with more elements in it and transfer all the old elements from the smaller array to the larger array. And then it'll take that element we're trying to insert and insert it into this new larger array. So as we keep adding elements, our array will resize as it needs to and update that num variable accordingly. Now, these arrays typically have a remove function, and if we called remove specifying a particular pointer in the array, then our array will simply remove that element and update the num variable. Now, Unreal Engine has the T-array, and it behaves just like this. It has functions on it, including add, which will simply take an element and insert it into the array. It also has add unique. Add unique allows us to make sure that we only get one of any particular value stored in the array. So if we're adding pointers, it'll search through the entire array and make sure that that pointer doesn't already exist in the array before inserting it. We also have remove, which removes elements from the array. And we can simply empty the array by calling empty on it. And then it'll dump all that information and reset num to 0. The T-array also supports indexing with the square brackets. So we could index array element 5 and perform some action on that pointer, such as using the arrow operator to call functions on that particular object pointed to by that memory address. But we do have to keep in mind that pointers could always be null, so that's something to be mindful of. We also have to be aware of the danger of indexing the array out of bounds. In this particular example, we have 6 elements in this array, with indices ranging from 0 to 5, so element 6 is empty. And if we attempted to index the array using an index that does not have a valid value in it, then we could get a crash with that array index out of bounds error. So that's the Unreal Engine T-array, and we'll see more use of it throughout this course. Great job. I'll see you in the next video.